Look at a simple feature request entering a highly specialized modern engineering environment. A basic code update arrives, and instead of moving straight to production, it bounces off a dozen different organizational walls. The front-end team hands the request to the back-end team. The back-end team passes it to the developers managing the API, an application programming interface, which acts as the bridge letting different software systems talk to each other. From there, it goes to the infrastructure team, and suddenly weeks have passed. The team at Vanoras calls this translation theater. Highly skilled engineers spend the majority of their day translating a single problem across different departments and service boundaries, rather than writing the actual code to solve it. The complexity of the software forces the team to manage the system's own internal borders. The architecture requires more effort to maintain its own existence than it spends doing useful work. This diagram shows how we arrived at this gridlock. Tech giants like Amazon and Netflix moved away from the monolith, a rigid architecture where all software components are built into one giant unified block. To scale up, they shattered those monoliths into microservices, breaking the application into tiny, independent parts. This allowed faster updates, but keeping them communicating requires them to frantically connect across an overwhelming, tangled web of cross-dependencies. Every single crossing point between those tiny parts adds latency. Every boundary creates a new surface for bugs to hide. Turning every minor function into its own isolated kingdom demands constant monitoring, creating a heavy coordination tax that buries engineers in maintenance noise. The structure of the software directly maps to the structure of the engineering department. A heavily fragmented technical architecture creates a heavily fragmented human team, leaving everyone exhausted by translation overhead. The researchers at Vanoras recognized a flaw in this setup. Not every specialized function actually requires its own isolated kingdom, its own deployment path, and its own service stack. This diagram illustrates an alternative inspired by the Baumkuchen, a traditional German layered cake. It presents one solid body with distinct concentric rings. Translated into software, this becomes a layered monolith. The system shares a central core, wrapped in strictly separated data layers. A unified core ensures stability and reduces operational overhead, while isolated outer layers allow teams to build specialized tools without disrupting the entire machine. This diagram details satellite-specific access points. External services dock into isolated layers of the core, eliminating the tangled connections of a microservice web. To coordinate updates, a central maintenance spine allows data to move cleanly between layers without breaking the docked satellites. As a business scales, the underlying philosophy remains intact. The system adapts by simply adding more layers or satellite ports, rather than tearing down the infrastructure to build new isolated kingdoms. Data is shared exclusively where functionally necessary. By strictly controlling data flow, the system eliminates the unnecessary crossings causing systemic fragility and burnout. Reducing the number of service boundaries provides immediate technical relief. Without the constant back-and-forth communication across servers, latency drops, the surface area for bugs shrinks, and overall server costs decrease. Curing the technical fragmentation directly cures the organizational fragmentation. Engineers are no longer forced into narrow, hyper-specialized silos. One person can once again see the whole building, enabling broader, multitask engineering without the friction of interdepartment handoffs. Clearing away the architectural noise and the endless coordination meetings gives the human mind the required space to step away from maintenance and return to high-level problem-solving. Freeing developers from translation overhead opens the door for effective HI/NHI teams, that is, human intelligence partnering directly with non-human intelligence. The non-human intelligence layer operates continuously beneath the surface, carrying the burden of repetition, scanning massive datasets, and detecting early anomalies. This elevates the human's role. Human intelligence operates in the structured node above, applying judgment, strategy, and handling complex exceptions. A disciplined, layered architecture stabilizes the core system and preserves human clarity. This structural coherence provides the foundation we need to finally partner with the next generation of intelligence.